Hi there. We are going to solve quadratic simultaneous equations. Before we start solving the equations, you need to understand what you're actually doing. So here we have two equations. This equation is equation of a circle. This equation is equation of a straight line. This is a quadratic equation. That's the first one there. This means there are two solutions, and this is a linear equation that has one solution, but in this case we need two solutions because, for example, if you have a circle that looks like that and you have a straight line that goes like that, what you are trying to find is where the two equations meet. So you have a straight line and a circle, and you're trying to find out where they intersect. And that's what you're trying to do when you are solving quadratic simultaneous equations. Now, normally you will solve simultaneous equation by either the method of elimination or substitution. Now, in this case, we cannot use the method of elimination because we cannot eliminate anything. This equation of this one, for example, doesn't have x squared, and this one doesn't have x. So the only way we can solve this is by method of substitution. Now, before anything, we need to name these two equations. We call this equation 1, this equation 2. Now, the best way to do it is to take the linear equation. So we take equation 2. So from 2, you can make y or x a subject. It doesn't matter. I'm going to make x a subject. So x is equal to 7 minus y. Now I can use this and sub into. So sub x, sub meaning substitute into 1. So instead of x, this time I'm going to write 7 minus y, which is this one here. X is that, but it's squared, so I need to square that one. Plus y squared equals 25. Now, hopefully you know how to expand this. This means expanding double brackets. So if I just do it over here, 7 minus y, 7 minus y, this will give you 7 times 7, which is 49. Y times that minus y times that will give you minus 7y. And then this time that will give you minus 7y, and then negative y times negative y, that will give you plus y squared, which will give you 49 minus 14y plus y squared. So that's that part there. I'm going to rewrite that and write it down. 49 plus beg your pardon, so 49 minus 14y plus y squared plus this y squared here equals 25. Collect like terms, so that's going to give you 49 minus 14y plus, so y squared there, 2y squared equals to 25. So I can see this is a quadratic equation, so I'm going to rearrange and make one side equals to 0, and I'm going to write the y's first, y squared first. So I've got 2y squared minus 14y. 49 take away 25, that will give me 24, so plus 24, and that's going to be equal to 0. Now, because there are the terms have all even numbers, 2, 14, and 24, 0, I can divide by 2 to eliminate these 2 here. So y squared minus 7y plus 12 equals to 0. Now, if you know how to factorize quadratic equation, and this is what you need to do right now. So 2 brackets, we need to find 2 numbers, 2 factors of 12 that will give you negative 7. So 12, I just do it again on the side. I've got 12, I can do 6 times 2, that doesn't work, will not give me 7. 3 times 4, Yes, that can give me 7, and they both need to be negative. Okay, so your numbers that will go on up here is y minus 4, y minus 3 equals to 0. From this point, you solve. So y minus 4 equals to 0. So therefore, y equals 4. And from the second bracket, y minus 3 equals to 0, y equals to 3. So you've got your two solutions. Now you've got your values of y's, you still need to find the x. So if I just say here, when y equals to 4, if I use my first equation, so I would say from 1, well, from 2, x plus y equals 7. X plus y equals 7. So when y equals 4, then I get x plus 4 equals 7. Therefore, x equals 3. Now, when y equals 3, x plus 3 equals 7. Therefore, x is equal to 4. So my solution then is x equals 3, y equals 4, and x equals 4, y equals 3. Okay.